All right, so picking up where we left off. So we'll be down here looking at module 11, looking at monopoly. So I'll kind of go through the rest of the slides today. I've got this Excel example that I think we'll have some time to work through. We'll have our participation quiz, and then I'll release that module 11 quiz after we are finished with class today. I think we'll have some time to work through some practice problems as well. One thing I did want to mention, under the Files tab, I put up this hypothetical grade tool. So just to give you an idea about how to use it. So it's going to take a little bit of effort on your part. So I've got 3 different kind of headings here. I've got the numbers in for like a hypothetical person. So notice like for the module reading, I put these hypothetical scores in. Module 13 hasn't happened yet. So you can kind of fill this in as we kind of, get towards the end of this semester. It will calculate your grade. Don't mess with these cells over here. The only cells you should be putting in is what your actual scores were in each assignment. It will then take that information and kind of compute what your current grade is. So right now, when I don't have a grade in here, it's not factoring that in. As soon as I put a grade in, now it's going to factor that in to those grades. So what this is doing is it's kind of showing you what your current grade is. This is what should match up with Canvas. Okay. So if you kind of look at Canvas, this should be the module reading grade you see. And then next to it is going to be the module reading score with that lowest one dropped. And then same kind of idea for the quizzes. Got a hypothetical person in here. So I have 3 quizzes I haven't entered in. It's going to tell you what your current quiz grade. This is what you should be seeing on Canvas. Here is what it is with the lowest 2 dropped. Notice it's higher. And then participation quizzes, same kind of idea. We have a lot more of those still left, but it kind of shows you what your score is. Not dropping those 4 lowest, and then what it would be if it drops the 4. So once you get your scores entered in, if you come over here to the hypothetical grade tab, it's going to pull that information from those other tabs. And this second row, so the first row is like a hypothetical, like someone does perfect on everything. Oh, and that was just to make sure I had all the formulas working. You'll then put in your first 2 midterm scores, and then you can play around with hypothetical final exam scores. Right? So this would be kind of the grade that you would currently see on Canvas, right? Without those lowest dropped. So you probably don't really care about this second column. It's just a way for me to check when I look at Canvas to make sure that everything's working correctly in this hypothetical grade tool. And then here with the lowest drop, it's going to be using those scores that notice are higher because it drops your 2 lowest quizzes, lowest module reading, 4 lowest participation quizzes. So I might even re-upload this file. It shouldn't say in class, it should say participation quizzes. And then once again, you can kind of play around with this final exam score. If I get a 90, it'll update this here. If you don't want to use that second row, you can always just enter in these hypothetical final scores down here. So I could do like, what if I get a 65? Okay, I'm still in the B range. What if I get a 55? Ooh, I'm starting to get out of that B- range. What do I need to get an A? If I get a 90, looks like I'm right on the cusp there. So something probably just over 90. So you can kind of play around with this hypothetical grade tool once you've got your current scores entered in and kind of update those 3 tabs as we have more quizzes, modules, readings, and participation quizzes come due. Okay. Any questions on that before we jump into material? And if you want to make sure you're doing it right, feel free to kind of email me. I can kind of double check what you're doing just in my grade book. But this is going to be, I think, a useful tool as we're getting closer into that final, thinking about what grade do I need to get, my desired score in the course. Okay. All right. So that's just under the Files tab. We are then going to jump into where we left off, which was price discrimination. Right. So I think we left off here on like slide 26, 27. But to kind of give us a recap of this, I'm going to start out today with the participation quiz. Okay. So this should be questions that we actually already talked about last class. So it's almost going to be like review where we left off, right? So I've got 3 questions, I believe, here. And 1, 2, 3. Yep. And they're all related to price discriminating monopolists. So if I'm thinking about, I've got this depiction, and I want to know what is the profit maximizing quantity, what will consumer surplus be, and then what is the value of deadweight loss for this perfect price discriminating monopolist. Okay, so that's not what I wanted to do. There we go. I'll draw these kind of side by side. So last class, we said, okay, so we've got quantity, quantity, price, price. Here we'll think about a single price. And then this is like a perfect price discriminating monopolist, okay? So I think the ones we looked at last class, we had constant marginal cost. We can actually do the same thing, but with increasing marginal costs. We said if there's a monopolist, they're a single price monopolist, they're the only firm, their marginal cost will become the supply curve, right? So if we think about where the perfectly competitive market would be, it's going to be at this quantity and at this price, where price is equal to, sorry, not price, where supply is equal to demand. So we're going to try to have this kind of in both scenarios, right? We've got marginal cost of the firm, that's supply, got our demand curve. Here's the quantity of the perfectly competitive firm and the price of the perfectly competitive firm. So we can kind of compare a single price monopolist to a perfectly competitive firm, a perfect price discriminating monopolist to a perfectly competitive firm. We said the single price monopolist faces a downward sloping marginal revenue curve that's twice as steep as demand. Okay. So they're going to make the profit maximizing decision where marginal revenue is equal to marginal cost. Okay. That's going to end up being, and here I'll call this kind of single price, right? Single price monopolist quantity. They then go up to the demand curve, and that's the price that single price monopolist is going to choose. Okay. So we'll notice a couple things. First, that single price monopolist price is going to be above that of the perfectly competitive firm. However, the single price quantity is going to be less than that of the perfectly competitive market. And then because we're seeing fewer units, we know a perfectly competitive market, the point where supply is equal to demand, that's where total surplus is maximized. So we said what's going to happen here, all of these units that we're no longer seeing produced, we're going to have some deadweight loss. Okay. And actually, just for the sake of this example, I'm going to color this green, right? So we've got some deadweight loss. What happens? Well, producer surplus is the area, right, between the marginal benefit of the producer, so the price, and their marginal costs. So we said these single price monopolists, they kind of almost look like price floors, right? And then what is consumer surplus? So here I've got my producer surplus. Could even do a single price monopolist. Whereas consumer surplus, well, the marginal benefit to them is represented by the demand curve. The marginal cost to consumers is this new price. So we said consumer surplus with these single price monopolists is going to be a little bit smaller than if we were at that perfectly competitive point. Okay. Now, if I'm thinking about a perfectly price discriminating monopolist, the whole reason we had this twice as steep marginal revenue curve is because when we were thinking about setting that quantity, we had to take a derivative of that total revenue function because the price quantity combinations we were choosing had to follow the demand curve. We were only charging a single price. With the price discriminating monopolist, at every quantity, we said they're going to charge however much this consumer is willing to pay for that first unit. So it's like we're going to have a bunch of prices. So there's not one price. Okay. So now, what is what would the marginal revenue of this perfectly price discriminating monopolist be? Well, it won't be based off this. It is the actual demand curve. Every quantity, they're setting the price or the marginal revenue they're making by selling each good, and this is supposed to be a 3, is going to be exactly the same as whatever the price is on that demand curve. So what's the difference between now that marginal revenue of the firm and their marginal costs? It would be this entire area, which notice, so this is going to be my producer surplus if they can price discriminate. Well, notice total surplus is maximized when we get to this perfectly competitive point. the price discriminating monopolist gets to that quantity. So total surplus is the same as a perfectly competitive market. It's just that all of total surplus is now producer surplus. Okay. And then what would consumer surplus be? Well, we said the price they're paying is exactly equal to their marginal benefit. So here we get consumer surplus with this price discriminating monopolist is equal to 0. And then if we're at the point that maximizes total surplus, deadweight loss is equal to 0. Okay. So I think the questions that we had there from the graph, we need to identify for this price discriminating monopolist, where does that demand curve hit my marginal cost? So go back up to question 1. So what would the profit maximizing quantity? We don't make a decision based off this twice as steep marginal revenue curve. For the price discriminating monopolist, demand becomes the marginal revenue curve. So it looks like I'd be at a quantity of, the grid lines are 2.5, so 22.5. Okay. And then what would consumer surplus be? Well, we said if I'm charging consumers exactly what their marginal benefit is, my consumer surplus would go to 0. And then what would the value of deadweight loss be? Well, if I'm producing up to the point where that demand curve, which is now my marginal revenue, is equal to the marginal cost, I'm at that perfectly competitive quantity. So I know total surplus is maximized, or the value of deadweight loss, I'm not losing any surplus. Okay. So even if we don't have constant marginal cost, the same things would apply, right? So we should have all these hopefully incorrect. The same rules would apply even if we have increasing marginal cost. Deadweight loss is 0. We're at that quantity where total surplus is maximized. However, all of total surplus is now producer surplus and consumer surplus is 0. And then kind of the key there was identifying that quantity was because the demand curve becomes the price discriminating monopolist marginal revenue curve. This twice as steep marginal revenue was for a single price monopolist. Okay. So we could actually make even more statements here. So if we're just kind of thinking about adding some things in, what's going to be true? Well, the quantity that a single price monopolist chooses, if it was below the perfectly competitive, it's also going to be below the price discriminating monopolist. Okay. Now we can't really say anything about prices because there isn't a single price, right? So we never would like compare the prices that a single price and price discriminating monopolist charges because there isn't just one price to compare, right? They charge a bunch of different prices. However, deadweight loss for this single price monopolist, it existed. Well, then that means it's going to be greater than when deadweight loss is 0. So the deadweight loss from a price discriminating monopolist will be less than that of a single price monopolist. And then total surplus of this price discriminating monopolist, well, if total surplus is maximized, here we're missing out on some, it's going to be greater than the total surplus of our single price monopolist. Any questions over anything there before we kind of complicate this a little bit? So we've looked at the most extreme scenario where we can perfectly price discriminate. And I'll give you some more examples of industries where we see this. It's, unlikely we see perfect price discrimination, but it is more likely that we see some level of price discrimination. So just some kind of summaries of the things we just talked about, right? They're going to see a higher quantity welfare or total surplus goes up, deadweight loss goes down to 0. Lower prices are charged to some individuals, right? So if we think about before, this was the price everyone paid. For some individuals, right, on this portion of the demand curve, the people that were more inelastic or were, sorry, I should say they were going to be more, we're closer to the inelastic portion of the demand curve. They weren't willing to buy this good until the price went down. So for everybody here, they're going to be paying a lower price than if they would have bought it before, even though they wouldn't have bought it. And then everybody here, they were paying this lower price. Now I can charge them higher prices. So for those people on the higher part of the demand curve, they're going to end up paying a kind of higher price. Okay. So I think we got that here. let me think if there's anything else I want to say. So I've got here, just a different way of kind of visualizing this. Oh, sorry. So let's say we don't have, I want to take all this off. There we go. So let's say I don't have perfect price discrimination, and then but I have some level, right? So I can't identify, every single marginal benefit of every single unit, but maybe I look at this and I say, okay, I know that for the first 20 units, the last price this person would be willing to pay is 300. So if I was charging a single price, I would charge 300 for those first 20 units. It's kind of like my single price monopolist. Okay. So if I were calculating profits, right? Now here with constant marginal cost, it kind of helps us out because if we assume there's no fixed cost, my marginal cost will be the same as my average total. So the difference between price and average total, producer's surplus with constant marginal cost in the long run just represents profits. So this is another way of saying producer's surplus here. Okay. But notice the single price monopolist, so they're earning what? They're selling 20 units at $300. Their marginal and average total cost would be 100. So we can kind of think about what's the value of producer surplus or profits, 20 times that difference of what, 300 minus 100. If I can price discriminate, maybe I figure out that consumers are willing to pay more for those first 10 units. So for the first 10 units, let's say if you only buy 10, I'm going to charge you $400 per unit. However, if you buy past 10, so this is kind of like a quantity discount. So maybe this is like bulk ordering from companies. If I start to buy more than 10, well, now the price you'll pay for the next 10 units between 10 and 20 would only be 300. I'll lower the price to you. Well, notice if I do that, I can make some additional money on those first 10 units. I'm making the same amount that I was before on those first 10, but now by charging this higher price for the first 10 units, I know consumers are still willing to buy them because that marginal benefit is 400. So I charge a price of 400. They're still willing to buy these first 10 units. Now, if I kept the price at 400, what would be true about every unit in this range? That price of 400 or the cost to consumers is greater than their marginal benefit. They wouldn't buy the next going from 10 to 20. However, if I lower the price, okay, I know that for every unit in that range of 10 to 20, they're willing to pay a price that's above 300. So if I lower the price to 300, I'll then sell those next 10 units. So I'm making the same amount of money I was before on the units from 10 to 12 as if I had a single price. However, if I then say, okay, look, if you buy more than 20 units, for every unit from 20 to 30, I'll only charge you instead of 300, only 200. Well, now for every unit in this range, the marginal benefit, right, or the consumer's demand curve represents marginal benefit, is above this new marginal cost. So now instead of stopping at 20, they'll buy the next 10 units, and I've gained some additional revenue there as well. So if I can price discriminate, I'll have this blue portion, which is really what my profits would be as a single price monopolist. But I can gain some additional revenue by charging these first 10 consumers or the first 10 units bought by charging a higher price than by setting a single price. And I can also make some additional money from these additional 10 units by charging a slightly lower price for them. Right? So, if I think about the additional revenue earned here, it would be 100 times 10, 100 times 10. So I won't have $2,000 of profits. I'm gaining another 2,000. So I'd have a total, I don't think I put it up here, but right, 1,000 plus 2,000 plus 1,000 would be 4,000. I've doubled my profits by price discriminating. And it's not perfect price discrimination, right? So I think I've got another visual, but you'll notice, well, what's the deadweight loss from this price discrimination? Well, we haven't gotten to that point where marginal cost or the supply curve would be equal to demand. So I'm still going to have some deadweight loss here. And what would each one of these triangles represent? Well, it's going to be the difference for the first 10 units at the price the consumer is paying and their marginal benefit. Next 10 units, the price they're paying for those, difference between that and their margin. Each of these little triangles would represent consumer surplus. Okay? So you can kind of think about the most extreme scenario, and then I'll kind of switch over. Well, I thought I had a slide. If not, I'll draw one out for you. Yeah, I don't, so I'll draw it out. So kind of a more simple kind of summary with perfect price discrimination is if I'm charging a single price, right? there used to be producer surplus, the difference between price, their marginal costs, up to the quantity they were choosing. If they can price discriminate, we said they get all the way out to this point where the demand curve becomes their new marginal revenue curve, hits marginal cost of the perfectly competitive quantity. So now all of total surplus, A, B, and C, is now going to be producer surplus. So with a single price monopolist, what happened to producer surplus? It's much larger. Now, what happened to consumer surplus? Well, before, at a single price, the difference between the price they were paying and their marginal benefit or the demand curve was area A. What did we say consumer surplus is if we can perfectly price discriminate? Well, there the price I'm paying is exactly equal to the demand curve. So consumer surplus would be 0. So consumer surplus, right, with price discrimination goes down. Same kind of thing, deadweight loss used to be area C. Well, that now becomes producer surplus. So deadweight loss also goes down to 0. So all of total surplus is now producer surplus. Now, if I think about a perfectly competitive market that was here, where would the perfectly competitive quantity be where marginal cost or the supply curve hits demand? What would the price be? If it was a perfectly competitive market, simply 100. So now that price being equal to marginal cost, my producer surplus would be 0. I've got no deadweight loss, but all of surplus, the difference between the demand curve and this new lower price of 100, all of that would be consumer surplus. So as we move from a perfectly competitive market to a single price monopolist, consumer surplus is going down, producer surplus is going up. If we can get to perfect price discrimination, consumer surplus goes down all the way to 0, producer surplus goes all the way up to being what total surplus was. So I'm going to draw this one out for us, just a different way of kind of thinking about this. So if I've got perfect price discrimination, or not perfect price discrimination, we had something that looked like this, and we said, okay, for the first 10 units, here will be kind of that first price. For the next 10, here's the second price, and then for the next 10, here's kind of that following price. Okay. And then I think what I had in there originally was like a lower marginal cost curve. Okay. So what's going to be true is that last price charged, we're at a quantity, we're not quite to that perfectly competitive quantity, right? So this would be like the quantity the perfectly competitive market chooses because marginal cost represents supply. So this is the quantity where the demand is equal to the supply curve. So even if they price discriminate, if it's not perfect, we would still lose out on this surplus. Okay. Now, once again, what is producer surplus? It's the difference between the marginal benefits, marginal cost of producers, or the difference between the price and their marginal cost. Well, for the first 10 units, that difference would be here. For the next 10 units, that difference would be here. And then for the next 10, it would be here. So producer surplus relative to a single price has went up. What's happened to consumer surplus? Well, consumer surplus, difference between the marginal benefits and marginal cost to consumers. The demand curve is their marginal benefit. The price they pay is their marginal cost. So for the first 10 units, the area between demand and price is here. For the next 10, here. Next 10 here. So to get total consumer surplus, we kind of add all those three up. The original consumer surplus at a single price was this larger triangle, right? So we lost some consumer surplus, gained a little bit here, but overall, we would see consumer surplus is going down because just by the nature of a linear demand curve, this rectangle will always have a larger area than that additional triangle gained. Okay. All right. So with that in mind, you know, in the real world, it's very difficult to see perfect price discrimination because, you know, you're not telling a firm exactly what your willingness to pay is. You know, so what do firms do? They have like, you know, try to do things based off of characteristics. So like, you know, there's senior discounts. They know that seniors are on a fixed income. They have a lower ability to pay. And so what do? They'll lower the price for them. Or student discounts. They know you're on a lower fixed income. Your ability and willingness to pay is lower, so they'll charge you a lower price. And then for individuals that have characteristics they think should have more disposable income, they keep that price kind of higher. Okay? So we could also see, like, so movie tickets, whatever the good is with senior student discounts. You also can see it not just based off of characteristics of the consumers, but you could have like discount coupons by if you buy more, like if you buy 10, get, the 11th free, or buy 3 of these and the price won't be $3, it's only $2, right? So that's an example where we're not charging different consumers different prices. We're charging the same consumer different prices if they buy higher versus lower quantities of the good. Okay, that would kind of look more similar to what we just worked through with non-perfect price discrimination. Some other examples, right? If you think about, you all actually don't pay the same tuition, right? So there's need-based financial aid, right? That's essentially price discrimination. It's lowering the cost to some individuals to attend college. Once again, quantity discounts, you can think about, this doesn't just have to be like if you buy 3, get 2 free. If you ever go in, like I have a terrible, I probably mentioned it, I have a terrible addiction to fountain drinks. Well, if you go in and get like a 24 ounce at a gas station of a pop, from the fountain, whatever the large machines, you're paying like, I don't know, 79 cents. But then if you want 36 ounces, it's only 89 cents. And if it's 44 ounces, it's 99 cents. That price increase, right? You're paying a lower amount per ounce. So it might be that as you buy more, right? It's, we don't think of that as a quantity discount, but essentially it is, right? The larger sizes, generally it's not like they double the price, even if the size of the good doubles. It's usually a little bit lower because they know, well, yeah, if you really wanted to quench your thirst, that you'd be willing to pay more for that first 24 ounces than you would for the additional, kind of additional 12 or 10 or whatever it is. Okay. So those are all examples of price discrimination. I would also say, and I probably should do some, I probably could have ChatGPT do this for me, but there's got to be some products now where if they're primarily sold online, your information and data is being collected all the time. Especially, I don't know if I mentioned this last class, but like places like Temu and like all these like things, well, they give you like exploding offers. You can guarantee, and I've done this with my wife, we'll see different offers on my account versus hers because it looks at our purchase history and it knows I am not willing to pay as high of a price for certain goods as she is, or vice versa. Right? So price discrimination is something that's a lot more prevalent now, that it's easier to gain access and information on consumers, right? I look at their previous spending habits. I know who is willing to pay more or less for specific goods. Okay. All right. So need to get through kind of one more topic here before we kind of jump over into Excel or look at some review problems. So let's say I'm going to keep marginal cost constant here to kind of make it a little bit easier. Let's say I'm thinking about generic drugs versus like new drugs. So I actually just had to go buy some Benadryl just in case, or someone has an allergic reaction. I bought the knockoff brand, right? So let's think about generic versus the name brand Benadryl. Well, let's say currently, right, this firm has a patent, right, on this drug. So no one else can copy it or mimic it. Where would the profit maximizing price be? Well, where does marginal revenue equal marginal cost as a single price monopolist? It's going to be where, at this quantity, they go up to the demand curve to set the price. So we're back to thinking about a single price monopolist now. Once that patent expires, other firms can join that market. What happens? It becomes perfectly competitive. They can no longer charge this higher price. What's going to happen is the price is competed down to that perfectly competitive point where marginal cost or the supply curve is equal to demand. So if we see these generic drugs pop up, the companies can't get away with charging higher prices, right? If it's literally the exact same drug. So what do we do, right? We got a problem, okay? So sometimes, why do we give patents? Because if these prices are driven down, if everyone can just copy the drug I'm coming up with, what happens to my profits? My profits are going to go, for a perfectly competitive market, we said profits are equal to 0. So if profits are 0, if I want to come up with a new drug, I've got to dump a bunch of money into research and development. So my costs are going to be high, but I know that my profits aren't going to change in the long run. Firms can just copy what I'm doing if I don't have a patent. So my gain, my additional profits would be, or my additional revenues would be, zero. Why would I spend all this money? Right? So what can happen? So this is an example of a market where if we have really large average total costs, right? So notice, or sorry, if we have really large fixed costs, which would give us very large average total cost, we can end up with a cost curve where the point where marginal cost would hit average total is at a point, right, where it's way past where that demand curve is going to hit average total cost. And this is going to present a problem for us. And we'll see why here in a second, I think. So if I was a single price monopolist facing this cost structure, looks like my animation's a little off, but I think you bear with me here, right? My line is a little off for some reason. But where marginal revenue is equal to marginal cost, that will be the profit maximizing quantity. I go up to the demand curve to set the price. Price is above average total, right? So price being above my average total cost, we're going to have positive profits. Okay. Now, the problem is, right, if I've got these positive profits, if I allow for firms to enter this market, what's the price going to get driven down to? Down here, at this lower price, what's true about price relative to my average total cost curve? Well, at any quantity, that price would be below average. So now profits are negative. Right? So what's going to happen, as soon as that second firm enters and they compete the price back down to the perfectly competitive price, well, now profits are negative. One of those firms will exit. We're back to just one firm. That's the idea that there's only enough demand given the current cost structure that supports one firm in this industry. Well, that's a problem because if we know that we have a single price monopolist, right? What do we also have? All of this surplus is lost, or we're not at that perfectly competitive quantity. We've got dead weight loss. Okay. So the only problem is if we are out at that perfectly competitive point, if we set the price down here, like if we used a price ceiling, well, we'd actually lower the price too much. Now profits are negative. Well, if this was a natural monopoly and I tried to regulate it by lowering the price down to here, if it's negative profits, that firm is going to exit. How many firms am I left with? Zero. What is dead weight loss? The entire market, right? So kind of what are some solutions, right? So we'll end up seeing that we want to set the price, right? If we try to set the price equal to marginal cost, we're going to result in negative profits for these natural monopoly industries. So what instead we're going to do is we're going to try to set the price at that point where the average total cost is equal to the demand curve. So I don't think I've got a slide left open here. I'll kind of walk us through what this will look like. So if I've got quantity price and I've got my demand curve here, and let's say, I don't even have to have constant marginal costs. I do need to, I might not save myself enough room, but I'll try. No, let me draw this again. I didn't give myself enough space. So got something that looks like this. Got our demand curve. Here's my average total cost curve. Let's say my marginal cost looks something like this. So it hits my average total cost at its minimum point. Okay. If I'm the government, so initially, right, if we have this single price monopolist, we know that at that quantity that they set, they're going to charge a price up here on the demand curve. They've got price above average total cost, profits are positive, right? If I try to set the price down here, so maybe I use a price ceiling, what's true about the price relative to average total cost? Well, at this quantity, right, the perfectly competitive quantity, price is actually below average total cost, profits would be negative. The firm exits. What is dead weight loss? The entire market, right? All of that surplus. Right? So instead, what is the government going to do? Well, they know that, okay, if I lower the price, let's say I use a price ceiling here. Right? So I've lowered the price, right? In order to kind of, if I want to think about, if I can force the price to be kind of down here, well, At this quantity, price is still above average total cost. Profits are going to be smaller. I've gotten deadweight loss to be a little bit smaller, right? Because I'm now selling these additional units. So I'm going to continue to lower that price until that price set by the government is exactly equal to, or is at a quantity, so we'll call this R for regulation, where price is exactly equal to my average total cost. So the firm knows, okay, my profits are equal to zero. I'm now indifferent about staying in this market or not. We still have some deadweight loss, but a little bit of deadweight loss is better than losing the entire market. So they're going to lower the price down to where profits are equal to zero for the firm, which is going to be where that price would hit my average total cost and where that would hit my demand curve. Okay. They would love to be at these higher prices, but if the government is using a price ceiling, they can't get there. Okay. Any questions on that idea? So, whoops. So what is the government going to do? We're going to lower that price to that point where average total cost hits our demand curve. That's where deadweight loss is going to be minimized. It won't be zero, right? But it's the best we can do without forcing or driving that company out of the market. Okay. So we kind of see some examples of this. If you go back and we've got all kinds of governmental policies towards monopolies. Essentially, if we think there's a natural monopoly, or sorry, a bunch of regulation that tries to break up monopolies, but there are some markets where the costs are just so high given demand, right, that it only has enough demand to support one firm. So what can we do? We can try to kind of set lower prices there. So the idea there being like a natural monopoly, especially back 100 years ago, the post office. So the government sets the price, right? So basically the post office, isn't making what they were ideally doing it. They'd set the price right at that point where the demand hit the average total cost. Profits of the post office would be zero, right? But we now have this, industry being supported. If we try to lower the price anymore, so profits are negative, now it just leaves. We're left with nothing. Okay. Let me think if there's anything else I want to say here. Okay. There are other technically things we could do. So you can imagine if I drove or I lowered that price to be at that point where profits were negative, I could still keep the price low for consumers, but then give a subsidy to our companies. For the sake of time today, I unless we have some time at the end, I'm not going to ask you questions like that, and to be kind of the next level of thinking of what we're doing. For us, when we're thinking about this natural monopoly regulation, we're just thinking about they would set that price exactly at that point where the price is equal to the demand is equal to the average total cost. Profits are zero. Okay. All right. I already kind of mentioned this. What's another thing that you could do? You also could just do nothing, right? Just allow the monopolist to exist as a single price monopolist. There will be deadweight loss. So that is a potential. It's not really very interesting, but that is something that you could do. All right. So a couple things that we haven't talked about yet with monopolists is, so we know that a pure monopoly is rare. However, we do have industries where one firm has like 90% of the market share and they have some control over the price of that product. Okay? And so even though they won't be at that perfect monopoly price, we know that monopolists charge higher prices in a perfectly competitive market. So even if it's not a pure monopoly, that price is going to be a little bit higher in a market where 90% of the market share is owned by one firm, as opposed to a perfectly competitive market where every firm is kind of sharing it equally. Okay. So another thing that we'll talk about here is, before I make this even more difficult, I'll introduce the idea of markups. Sorry. So if I was thinking about this monopolist, just a regular monopolist, so I've got increasing marginal costs, downward sloping demand curve, single price monopolist, downward twice as steep marginal revenue curve. Marginal revenue is equal to marginal cost at this quantity. Up here, this is going to be kind of our price the monopolist sets. Okay. So we went through last class a little bit and kind of talked about okay, this deadweight loss that's created, what is the base of that triangle always going to be? Well, the point where marginal cost of the monopolist, which is just they're the only firm, so that's supply, is equal to demand, that'd be the perfectly competitive quantity. So we said this difference between the perfectly competitive quantity and the quantity the monopolist chooses, I don't believe this pops up in the reading, and I won't ask you questions on it related to Module 11, but it'll come back up in Module 12. We would kind of call this kind of the excess capacity of the firm, right? So it's all the units they could be producing that would generate some surplus for society that they aren't, right? It's their excess capacity to increase total surplus. And then what was the height of that triangle? Well, that was always going to be the difference. So here, this was like the marginal cost, right, of the monopolist. So price of the monopolist minus the marginal cost of the monopolist would be our height of that triangle. And then we have linear supply and demand, so we multiply by a half. That gave us our deadweight loss. The difference between price and marginal cost for the monopolist at that last unit they produce is what we're going to call the markup. Okay. So the markup is how much higher above my marginal cost am I setting that price? Okay. So got kind of an example here in the slides. And oops. So let's say I'm looking at kind of two different, monopolists. They have two different marginal cost curves facing the same demand curve, just to kind of simplify that. So the first monopolist, where would marginal revenue hit marginal cost? Right here at this quantity. So their marginal revenue or their marginal cost here is at this point. They go up to the demand curve to set the price. You kind of notice the markup here initially, relatively good size. However, if the firm can lower their marginal costs, right, facing the same demand curve, they're going to increase the number of units. The profit maximizing quantity will be higher now because same marginal revenue, but now my marginal costs are lower. Every unit in this range, before the marginal revenue was below my marginal costs, so I didn't produce them. Now every unit in that range, the marginal revenue is above my marginal cost. So they'll increase the quantity that they're producing if they can lower their costs. And then what happens to the markup? Well, the price they set, the difference between that and the marginal revenue is going to be even larger. And the reason why that's true, and it's maybe harder to see on that, so I'll draw this out in a slightly different way. So if I've got my demand curve and I've got my marginal revenue, I think it's kind of intuitive that when my costs go down, if I'm choosing the quantity where marginal revenue is equal to marginal cost, my new quantity is going to be higher. So if I think about like looking at these different quantities, because this is twice as steep, that gap in between the price they set and that marginal revenue, right, which will be kind of their marginal cost, that really this is the same thing because marginal revenue is equal to marginal cost at the profit maximizing quantity. That markup, as I look at higher quantities, we'll notice what's happening. It's getting larger and larger. Okay. So the markup of a firm, as their costs go down, holding constant kind of the demand for their product, the markup is going to be going up. Okay. Also, what will end up being true is that kind of gap in between the quantity that the monopolist is choosing and the perfectly competitive quantity. Notice initially it's kind of small. Now it's relatively large. So that excess capacity being created is going to be even larger as we see these lower costs as well. Right? And then you could put in some average total cost curves and kind of figure, okay, for the firm that was facing these marginal costs, right, at their optimal quantity, what's happening to profits? Well, initially, the difference between price and average total cost, right? My profits here would be difference between price and average total times the quantity they're producing. At this lower cost, the difference between price and average total times the quantity I'm producing, well, I'm selling more units, and that difference between my price and average total is now larger, so we're going to see profits of the firms go up as their costs decrease. And once again, I think that's relatively intuitive that if a firm can decrease its cost curves, it's going to increase its profits or producer surplus, and that markup is going to increase as well. Okay. All right, where are we at in time? We got 30 minutes left. So what do I want to do with the remainder of class? So I think this example is interesting. Although, given the time that we have, I don't want to, let me see here. There we go. We'll spend 10 minutes on this. I want to have at least, the remaining 20 minutes to kind of go through some practice problems, but I think we can kind of work through a lot of this, and it also highlights a lot of the different things that we've talked about when related to monopolies. Okay. So if I was just giving you two things, so I'm going to give you the price and the quantity of the firm. So what am I really giving you when I give you this information? Price quantity combinations, that's the demand curve. I'm also giving you what the firm's costs are. So am I in the long or the short run in this example? Well, if my total costs are zero when quantity is zero, that means my fixed cost must be zero. I must be in the long run, okay? So I would, on a problem on the exam or a quiz, if I'm asking you about what's the optimal quantity for this single price monopolist or a price discriminating monopolist, I could give you just this information and ask you to calculate profits, quantity, price of the single price monopolist. So how could you do that? Well, I wouldn't give you this many to do, but I'll show you how in Excel we could do it for really like 100 different price quantity combinations. So what is total revenue? That's simply going to be my price multiplied by the quantity. Okay. So I would go through and do that for every single price quantity combination I have. Now these numbers math's not quite as easy as the numbers I would give you on a quiz or exam, but I've now got my total revenue. How would I find my marginal revenue? Well, marginal revenue is the change in my total revenue. So it's going to be the new total revenue minus what was the total revenue at the previous quantity, and then divide that by what is my new quantity I'm producing minus the old quantity. Okay. So, 608 divided by 8, that would be my marginal revenue. I would then want to do that for every single kind of price quantity combination. What should be happening to my marginal revenue when I copy this down? It should be decreasing, and it should be decreasing faster than the price. In fact, how much faster? Well, the price for every 8 units I go up, the price is falling by 4. So for every 8 units I go up here, hopefully that marginal revenue is falling by 8. Sure enough, it is, right? That's kind of what we talked about, that relationship between the demand curve and the marginal revenue. Marginal revenue will be twice as steep, okay? Make sure there's nothing, okay. All right, so I'm then going to do, okay, what are my average total costs? Well, my average total cost will simply be the quantity I'm producing, multiply that by, thinking about profits. We need average total cost to compute profits. So what is my average total cost? It's my total costs divided by the quantity I'm producing. Okay, so we'll hit kind of enter there, right? And then we'll copy that down. So I now have my average total cost. Once again, should be a U shape. Initially, they're decreasing. And then at a certain point, my average total costs start to increase again. How would I find marginal cost? That's just the change in my total cost. So what are my current costs minus the cost of the previous quantity I would have been producing at, divided by a change in quantity. Here, I could find the change in quantity. Now, in this example, it's always 8. So if it's easier for you, if you were you could just put 8 in here. Like if we're doing this by hand, you can just, oh yeah, that change in quantity is 8. But if I wanted to change this later on, I'll kind of show you how if I build all this out, I could look at any demand curve. Okay. So I've got my marginal cost. What must be true about these first, where are we at? Yeah, 24 units. If my marginal costs are going down, the firm must be experiencing gains from specialization. And then after that quantity of 24, my marginal costs are increasing. This is diminishing returns is taken over. So I can calculate profits in 2 different ways. I could say, okay, take my total revenue, subtract my total costs. That's one way of finding my profits. Okay. If what I told you is true, the other equation we had should give me the same values. I would take the quantity I'm selling times the difference between the price and my average total cost. That should give me the exact same values right? Just a different way of kind of computing that profit amount. And then here I could do, I forget what I had here, but I think I used like an if statement. I'm not going to make you guys do this, but right, you could say, okay, if the marginal revenue is greater than or equal to our marginal cost, comma, if that's true, put the word yes, I should produce this. If it's not, put no, I shouldn't be producing at this quantity. Okay. So initially, my marginal revenue is greater than marginal cost, so I'll produce the first 8. Will I produce the next 8 up to 16? Well, marginal revenue is still above my marginal cost, so yes. At this point, right, I should say, okay, at that quantity of 64, is my marginal revenue greater than or equal to? No, it's not. So I wouldn't produce that 64th unit. The last unit where marginal revenue is greater than marginal cost would be at this quantity of 56. Okay. So we can kind of identify this would be our profit maximizing quantity for the firm, for the monopolist. And then what price would they charge? Well, at that quantity, what price is the consumer willing to pay? 52. So this would be the single price quantity and single price monopolists profit maximizing quantity and price. Okay. Right. I don't know what I had here. For the sake of time, we'll kind of skip that. This is just kind of quickly identifying what that is. So where are profits at their highest? We'll notice if this is the profit maximizing quantity and price, when I calculated profits, sure enough, that's where they were at their greatest value. Okay. All right. And then what did I do here? I think I just had like, okay, yeah. Well, I won't worry about these if statements for the sake of what we're doing. Now you could also do this for the perfectly competitive market. So here, when will they produce? So as long as the marginal revenue is greater than or equal to the marginal cost, but what is the marginal revenue for a perfectly competitive firm? It's simply the price and the market, right? That was their marginal revenue. So if that price is greater than the marginal cost, put in the word yes. If not, put in the word no, that they should be producing that quantity. Right? So if we drag this down, what should be true about the profit maximizing quantity of the perfectly competitive market, it ends up being at a higher quantity. Right? So here, right, our perfectly competitive market will get to a higher quantity and set a lower price. Okay. So just kind of a way you can do this in Excel. You could do all of this by hand, right? But I don't know. I just thought it was worth kind of seeing that you can do this with a larger set of numbers, okay, and numbers that are a little bit more tricky. And then if I had something like this built in Excel, well, notice what if I now have a, say I wanted to start this out at 200, everything would update, right? Now I would have like, could change my quantities as well. Instead of being +8, you know, I could have the jumps being, oh, I don't know, 10. Right? So I could say, what if that was my demand curve? Now it kind of, everything kind of updates and I can identify. Now this one's not interesting because I should be, you know, producing at every quantity. I'd have to kind of keep going. But I can update those values as long as I have built everything using these formulas. Okay. Once again, I'm not going to make you use Excel, but just I think worthwhile to see how you would kind of put this into practice. Also, I try to put resources out there that are going to help you, I think, in other classes. I'm sure you'll be using Excel in many of your other classes in Kelly. Okay. All right. So let's go to the home page here. And oh, I put up module 12's materials as well. I forgot to mention at the beginning of class. So let's look at these practice problems. And there's a couple I think that will be worth our time to kind of work through here today. Unless, if anyone looked at this ahead of time and has specific problems they want to see worked through, I'll start with those. Otherwise, I'll kind of pick and choose the ones I think would be helpful for this quiz. So let's do this one. It's kind of similar to what we just kind of worked through. So let's say I had this demand schedule, this price and kind of quantity combination. I can calculate the marginal revenue of, and here it's a single price monopolist. Okay. So I'm just going to write this down real quick, and then we're going to go just where I can write this out. So 18, 15, 12, 9, 6, 3, 0, 1, 2, 3, 4, 5. Okay. So I've got these different quantities and these different prices. Okay. If I wanted to find the marginal revenue of the third unit, what would I do? Well, in order to total revenue, what is total revenue? Simply price times quantity. So this would be what? 0, 15, 24, 27, 24, 15. My marginal revenue is the change in total revenue from a change in quantity. Well, here my changes in quantity are 1, so that's nice, right? So no marginal revenue if I produce nothing. The very first unit, the change in my total revenue, 15 divided by a change in quantity of 1, so 15. Here it goes up by 9, 3, -3, and then what? -9. Okay. Now, just for the sake of this, if I had jumps of 10 instead, what would my marginal revenue be in that case? Well, it would still be the same change in total revenue, but divided by a change in quantity of 10. So this would just be 1.5, 0.9, etc. Okay. So just because the jumps are 1 here, it won't always be that case, or that won't always be the case. Okay. So that marginal revenue of the third unit, like we had calculated, was 3. Okay. If the marginal cost was 9, what would the profit maximizing quantity be? And what would we consider demand at this point? Okay. So if we're looking for when the marginal cost is constant at 9, the profit maximizing quantity is where marginal cost is equal to marginal revenue. So that's going to be where, well, marginal cost would be equal to marginal revenue at a quantity of 2. Right? So the quantity of this single price monopolist would be 2. What price are they going to set? Well, they are on the demand curve, so that price at a quantity of 2 is $12. Okay. Now, marginal revenue, when it's positive, we said what is true about demand. Okay. So this is going to be going back, and you could go ahead and calculate your percent changes in price and quantity here, but probably an easier way to do this is just to remember, whenever I'm looking at my demand curve, there will be some unit elastic point in the middle. The higher part of that demand curve is going to be elastic, the lower part inelastic. Okay. So my marginal revenue, we said when my marginal revenue is positive, I'm on the elastic portion of my demand curve. When my marginal revenue is negative, I'm on the inelastic portion. Okay. So we know that, as long as my marginal cost is anything above 0, the profit maximizing quantity should be where marginal revenue is positive, and I'm on the elastic portion of my demand curve. Okay. If I was somewhere on this elastic portion of my demand curve, right? Well, we'll hold off on that, right? So what about the unit elastic point? That's where marginal revenue is equal to 0. Okay. Now, if instead I'm thinking about what if I had a price discriminating monopolist? Okay. What could be true? So let's say I had a marginal cost that looks something like this. If I'm price discriminating, I don't make the decision where marginal revenue is equal to marginal cost. I would actually choose where the demand curve becomes my marginal revenue. So I could end up at a point where if I'm price discriminating, marginal revenue would be negative if I was not price discriminating, acting like a single price monopolist, or a price discriminating monopolist can end up on that inelastic portion of the demand curve. Okay. So I think the next question, right? Let's say we could practice perfect price discrimination, and what would kind of the optimal quantity be for the firm to sell? So I don't actually, let me see if that question 8. No, but I'll answer. I'll give you that additional question. So we'll answer 7 and then we'll kind of come back. So if I had perfect price discrimination, well, no. Before we answer 7, I'll do this one. Okay. Let's say I had that the marginal cost was constant at 6, and I've got a perfectly price discriminating firm. Okay. So I can calculate marginal revenue and deadweight loss for this perfect price discriminating, but we're going to kind of come back to this. Okay. So if instead I had a constant marginal cost of 6, right? Well, I wouldn't be using this marginal revenue column to decide where the price discriminating monopolist would choose. They're going to set, remember, their marginal revenue is simply that demand curve or the price. So where marginal revenue is equal to marginal cost of 6, I'm just looking for where does the price equal 6. That's going to be true here at a quantity of 4. Notice what's true about my marginal revenue. It's negative. So we said if marginal revenue is negative, the price discriminating monopolist would actually be on the inelastic portion. Okay. So these price discriminating monopolists can end up on the inelastic portion of their demand curve. And the way that you would identify where the price discriminating monopolist chooses the optimal quantity is not where the marginal revenue is equal to my marginal cost, but where that price is equal to my marginal cost, because the demand curve is their marginal revenue curve. Okay. And then if I wanted to know the marginal revenue of the third unit, well, if I'm looking at the third unit, if I'm a price discriminating monopolist, how much are people willing to pay? $9. That's how much I would charge for that third unit. So the marginal revenue is the price. So that would be $9. And then what is deadweight loss? Well, if I can perfectly price discriminate, and this is one where it can kind of help you rule out some answers. If you can perfectly price discriminate, you know that your deadweight loss will always be 0. So 9 and 0 would be kind of our combination of answers there. Okay. Any questions on any of those or anything that I said there before we keep moving? Okay. Oh, let me think. What do I want here? Setting the price equal to constant, blah, 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 blah. Oh, I thought there was another one in here that I wanted to make sure. Oh, here's one. Okay. So if I was looking at kind of a graph like this, right? Hopefully some of these are going to be easy, so I'm going to go through them a little quicker. But if I had a single price monopolist, they're going to produce where marginal revenue is equal to marginal cost. So that'd be a quantity of 15, go up to the demand curve to set the price of 24. Right? So, what am I going here? Oh, because I'm asking about what profits are. So we've got the price is 24, quantity is 15. How would I calculate profits? What's the difference between price and average total cost times the quantity I'm producing? So what? 4 times 15 would be 60. Okay. So we can identify the single price, profit maximizing quantity, price, and then amount of profits. Okay. What would the deadweight loss be? Well, if this wasn't a monopoly market, we'd be where, well, marginal cost of a monopolist would just represent the supply curve. So we'd be out here at this quantity of 25. So we're missing out on all of the surplus, or the area in between the demand and marginal cost curve or the supply curve, for all of those additional 10 units that are no longer being produced and sold on the market. So just the area of this triangle, height is 12, base is 10, 10 times 12 is 120, multiply by 1/2, we should be at 60 for our deadweight loss. Okay. If we're looking for the point that satisfies allocative efficiency, right, we're looking for, okay, allocative efficiency, that term was when total surplus in the market is maximized. So in this example, where would the perfect price discriminating monopolist choose? Well, their marginal revenue becomes the demand curve. So marginal revenue be equal to marginal cost. Oh yeah, that's the same as supply equals demand. the perfect price discriminating monopolist gets to that point that the perfectly competitive market would choose. So the same quantity, right? It's just that they're charging all consumers exactly what their marginal benefit is. So we end up with deadweight loss of 0, but all of surplus becomes producer surplus. Now notice, if they're perfectly price discriminating at this quantity of 25, what is true about the marginal revenue curve? I didn't draw it down here, but if it's 0 here, at these higher quantities, it has to be negative. Excuse me. So that quantity of 25, marginal revenue is negative, so I know I must be on the inelastic portion of my demand curve. Okay. Excuse me. And then if I had a perfectly priced discriminating monopolist in this graph, profits of that perfectly priced discriminating monopolist would be what? Anytime I'm asking about profits, I probably would change my language a little bit on the quiz or exam, where we're really thinking about if I'm charging all of these different prices, right? The amount of money I make on every single unit would simply be the difference between the price and my marginal costs, right? In the long run, because fixed costs go to 0. So really, producer surplus in these perfectly price discriminating monopolist examples, we can think of that as profits. So if I have a perfectly price discriminating monopolist, they're going to get out to this quantity of 25. The difference between the demand curve and marginal cost, all of surplus, that would represent the profits for that price discriminating monopolist. So here we'd have what? 26 times 25 times a half. Can't do that math in my head, right? So 26 times 25 times 0.5, right? Should be 325. Okay. Any other questions there? Let me think. Okay. I'm down here. Okay. Let's do some more with, well, we haven't really worked through one like this. So I think I'll do 12. And if we have time, we'll kind of come back to these ones that have the equations that we kind of looked at last class. So let's say I have a monopolist and they are selling a product and it experiences an increase in demand. Which of the following would not be true? Okay. So if we think about what this would look like, and here, I think for the sake of this example, I'll keep marginal costs constant just to make this a little bit easier to visualize. Okay. So if I had, let me make sure I have everything in the problem. So what? Single price monopolist experiences demand. Which of the following is not true? Profits, prices, quantity. Okay. So here's my original demand. Here's my original marginal revenue curve. Okay. So initially, profit maximizing quantity is here. Go up to the demand curve to set that price. We said with these constant marginal costs, we can think of, even if I don't, my average total in the long run would just, if my costs are always the same, my average cost is always the same. Okay. So we could think about profits here for the firm are just going to be kind of the difference between price and average total cost, right? So that would be this here times the quantity they're selling. So this kind of represents my initial profits. Okay. If this firm experiences an increase in demand, what's going to happen? Well, I'll draw this pretty extreme, but let's say the demand curve goes up like this, twice as steep, kind of marginal revenue curve. Well, anytime the demand curve increases, my marginal revenue curve would have to increase as well. It is the same as my demand curve, just twice as steep. So notice the quantity from a demand increase would always go up, right? Well, we said before, what happens as we look at higher quantities, the gap in between demand and marginal revenue is going to get larger and larger. So that price, when we have that demand increase, it's going to increase the quantity. It's also going to increase the price. Okay. Now, we can kind of see if, as long as marginal costs don't change, I've just seen an increase in demand. What's going to happen? Well, if my price is higher, the difference between my price and this average total cost curve is going to be larger. Now, this entire area would represent profits. So we've seen that the quantity went up, the price went up. Well, if quantity and price both go up, we must see profits go up as well. Okay. And I wouldn't, I probably would throw the caveat in there, assume that you have constant marginal cost just to kind of make it drawing it a little bit easier. Gets a little bit more complicated if we had increasing marginal cost, but the same sort of idea would apply. Okay. So we were looking there. Oops. There we go. So we said, which is not true. Well, profits are going to go up. We said they would choose a higher price. So this should be the one that's not true. Higher quantity, and the monopolist will experience an increase in marginal revenue. Anytime there's an increase in demand, I didn't really spend as much time saying that, but there would have to be an increase in my marginal revenue curve as well. All right, so we've got just a couple minutes left, so I'll probably hold off on kind of doing any additional problems. So that should do it for module 11. In fact, before I even end this recording, we'll go down here, kind of have that quiz released, right? So that'll be due by the end of the day, Sunday. We will start module 12 tomorrow. So that module reading is due before we start class. It's talking about game theory, oligopolies when we have a small number of firms. So we'll start that tomorrow and then finish it up on Monday. Other than that, I'll kind of end the recording here. If you have any other questions, I'll kind of hang around for a little bit.